Hey guys, so we are down to 2 more sets of notes for the school year, and each one of them are going to combine 2 lessons together. So we're going to be talking about mean, median, and mode. Now, these guys are also known as measures of center. And what that means is they represent the middle or average of a set of data. Okay, and each one of these measures of center measure it a different way. Okay, so let's start with the easier ones, and then we'll go to the harder. And by that I mean the easier ones are quicker to calculate, and the harder one just takes a little bit longer, but it's really not that hard. So let's start with median. What is a median? So the median is when numbers are when numbers are listed in order from least to greatest. The median is the number physically in the middle. Okay, now I'm going to highlight order from least to greatest. That is crucial. If you don't put the numbers in order from least to greatest and just take whatever number is physically in the middle, then you got trouble. And just give you a little bit, think about the word median. Looks like the word middle. Okay, kind of starts off the same way. Median, or it said it there, almost sounds like medium. Okay, they all mean the same thing. It's the size in the middle. It's the median is actually, if you see like a cement thing down the center of a street and there'll be like trees in it or plants or whatnot, that's called a median. It's splitting the 2 directions of traffic from each other. Now, the interesting thing is sometimes a median is not actually a number in the data set. I know, weird, huh? So let me just kind of talk about that for a moment. So if you have an odd set of data, so what I mean is you have 3 numbers or 7 numbers or 13 numbers, okay? So let me give you an example. Let's say we have 2, 4, 8, 9, 16. So we have 5 numbers in the data. There's a couple ways that you could think about it. Is you could take however many numbers you have and cut them in half. You get 2.5. So it's saying the number that's after the second number would be in the middle. Another way I think kids have explained to me, their teachers told them, is you kind of work from the outer edge to the inner until you only have 1 number left. And then he would be the median. Median is 8, okay? But if you have an even set of data, it gets a little weird. Okay, so let's do an example here. So we've got 3, 5, 9, 10, 12, 15. So we have 6 numbers in the data. Okay, so what this one is, if we did that way that some of you had learned, where you start on the outer edges and you start working your way in, when you do it with this guy, all of a sudden you've run out of numbers. So what you need to look at is in between the two numbers. So the median falls between the two middle numbers. Now this one's pretty easy to figure out. What's halfway between 9 and 10? And you say, well, yeah, that's easy. That's going to be 9.5. Okay. So the median is 9.5 or 9.5. Okay. So kind of strange. So we're actually figuring out mean when we have an even amount of numbers in our set of data, and we're looking for median. So we're actually finding the mean of the two middle numbers. So we'll get to mean in a second. Okay, mode is, I like to call it the middle school thing. Mode is about what appears most often. So the number or numbers, because you can have more than one, appear most often. So here's something you need to understand. If they all appear twice, there's nothing that appears most. Okay? They're all appearing the same amount. So you need to have a number that appears more times than any other number. All right, so that's what's important on this one. So the reason why I say it's kind of a middle school thing, and I'm going to put here the word most, because that's really what this is about. Most and mode sound very similar. It's about popularity. What's popular? Oops, popular. What's popular? Okay. So here's the funny thing about mode. There could be no mode. That means all the numbers appeared exactly the same amount of times. There could be one mode. So there was one number that stood out larger than, in more quantity than any other numbers, or more than one mode. And it's just whatever the data is all about, okay? So again, no mode means the numbers all appear the same amount. So I'm going to talk about this guy. All numbers appear, maybe if I could spell today, the same amount of times. Okay. Now, the other guy is our mean. Now, he's going to be, the mode is actually the easiest because you don't have to ever calculate the most mode at all. Median, sometimes you'll have to calculate, but the guy you're always going to have to calculate, that's going to be your mean. So the mean is the number, it is the average of the numbers in a set of data. So the one thing that really kind of makes the mean different is that you must calculate it. Okay. Mode, you never calculate, and often you don't calculate median either. So how do we figure out what it is? Well, first thing we're going to do is we're going to add up all of the numbers. Okay. After we add up all the numbers, then we're going to divide the sum by how many numbers were added together. So it's easy to get a decimal on this one. Now, so all of these go back to trying to tell you what is average. So when you're reading in a newspaper, magazine article, or you hear in a TED Talk or newscast, and they're talking about the average American, you don't know which one of these three measures of center they're talking about. You don't know whether it's the number that fell in the middle of all the numbers that they gathered. You don't know if it's the one number that showed up most often compared to the other numbers. You don't know if this number was the result of adding all the numbers together and dividing by how many numbers were there. Now, each one of these will get affected by something called an outlier. So let's talk about him. If you think about it, the word outlier is something that's lying outside of the rest of the data. So it's a value that is either smaller or larger than the majority of the data. Okay, so if you have, let's say, the number 1, and the next number in your set of data is 25, that 1 is going to get added with all those other numbers, and it's going to make your mean look smaller than it should. Okay, so an outlier has a major effect on the mean. It has a major effect on the mean. And in fact, that effect, we call it, is being skewed. You can either be skewed positively or negatively to the left or to the right. People describe that skewing as a tail. Okay, these are all things that you'll learn more about in subsequent years. Okay. Now, the interesting thing is the outlier doesn't really affect the median that much. That's why people like using the median. Doesn't really have an effect on mode or median. So, regardless of what they're asking you to find, whether it's the mean, the median, or the mode, big idea here. When doing statistics, start by lining up from least to greatest. Well, this doesn't really help tons and tons when it comes to doing the mean. You can't do median, and it's far simpler to find mode if the data is written in order from least to greatest. Okay? So let's go ahead and we're going to practice all these 3 pieces of interesting statistics. And we're going to start with Actually, we're not going to separate it out. We'll just do mean, median, and mode of a couple different problems. So I'm going to go to my next screen, which would be my second page of notes. So I'm going to retitle it. Lesson 11-1/11-2, mean, median, and mode. And really, we should call it mode, median, and mean because of the progressively harder issue. Okay, so we generally are going to be given data in either in a set, like in a table of values. We might be given data in terms of a dot plot, which is a number line with dots representing how many times each number shows up. You might see it in something called a stem and leaf plot. In fact, I'll do one of that so you can see what that looks like. But we're going to do a couple of basics, and then we'll go on from there. So find mean, median, and mode. So we'll just do 3 examples. So first example is going to be number of monkeys. So there's some zoo that is, I think it's 11 different zoos, and they counted up how many monkeys they had. And so they gave the data in just kind of a random pile of values. Nothing really organized or whatnot. So there was 28, 36, 18, 25, 12, 44, 18, 42, 34, 16, and 30. Okay, so let's start by putting them in order from least to greatest. Okay, so let's start there. So how I do it is I look for my digits in the tens, so I have 18, 12, 18, 16. So in order, 12, 16, 18, 18. Now, I did have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just going to make a note that there's 11 numbers. So when I'm putting my numbers in order from least to greatest, I'm going to double check to make sure I have it in 11 numbers. Okay, so the next grouping would be the ones in the 20s. So let's see, I have a 28, a 25, and that's it. So that's pretty easy, put in order, 25, 28. And then I look for any numbers in the 30s. So I've got a 36, a 34, and a 30. So in order from least to greatest would be 30, 34, 36. And then let's see, what else do we have? 40s. We have 44 and 42. So that would be 42, 44. Okay, now that I put them in order, it's going to be easy to find mode and median pretty quickly. So let's look. I'm looking for a number that repeats, and I do see a number that repeats. I see 18. Okay, so 18 monkeys would be the mode. Now, wouldn't that be interesting? Is if in a newspaper article they said on average there were 18 monkeys in each of these 11 zoos. Look where 18 is compared to the rest of the data. I don't think it's very representative. Okay, for median, because I have 11 numbers, if I work my way both places, I end up with one number in the middle. And so that would be 28 monkeys. Now, I would say that seems more representative of from 12 to 44. I like that. But now we're going to have to do the biggie, and that's going to be the mean. So the mean says we're going to take all 11 numbers, we're going to add them up, and then we're going to divide by 11. Wow, that's a lot. So what I do is just kind of pair them up by 2s. That's how I get started. So 12 and 16 is going to give me 28. 18 and 18 is going to give me 36. 25 and 28 is going to give me 53. 30 and 34 is going to give me 64. 36 and 42. Let's see, well, 36 and 44 is going to give me 80. 80 and 42 is going to give me 122. Okay? Now, all of that's going to get divided by 11. So then I'm just going to continue to add. And let's see what we end up. So I take these two guys, and maybe I could, yeah, I'll just take these two. So the first two would give me 64 plus 53. Oh, let's add the others. Let's make it 53 and 64 is going to give me 117, and then plus 122 over 11. And then I can continue adding, so I get 11. See, this one takes so long. And then we get 2, 8, 181, and 122, oops, over 11, which is now going to give me 310, 303 over 11. So then I would divide 11 into 303. So 11 goes into 30 twice, which is 22 with 8 left over. And 11 goes into 83 7 times, which is 77 with 6 left over. And I would write it this way. I wouldn't do it as a decimal. Some people may say it's about 28 because 6/11 is over halfway. So I would say this is 27 and 6/11 monkeys. Now, I think we've had this conversation before. When that doesn't quite sound good. I mean, I know what a monkey looks like, but I don't know what 6/11 of a monkey looks like. So you got to understand that statistics is not about actual real things. It's just about with the numbers, okay? Now, I'm fine with that answer. You could do more division and get a decimal version of it, but whatever, okay? All right, let's do another one. Same sort of idea. Let's do test scores. Nice thing is we're not going to have so many numbers. Bad thing is the numbers are bigger. So this is somebody in a math class. They scored a 93, an 88, a 94, a 93, an 85, a 97, and a 90. Wow, they must be doing their homework. So we're going to go ahead and put them in order from least to greatest. So let's look at, we went to 80s and 90s. So 80s, we have 88 and 85, which is in order 85 and 88. And then for the 90s, it's all the rest of the numbers. So we have a 93, a 94, a 93, a 97, and a 90. So we start with a 90. We have a 93, and a 93, and a 94, and a 97. So we had 3, let's see, in this one we had 3, 4, 5, 6, 7 numbers. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, good. So let's go through our easy ones. Let's do mode and median. So mode's super simple. We just look for a number that repeats, and we see that repeating with 93. So 93, and I'm going to say it's a percent score, okay? And then for median, again, I have an odd set of numbers, so when I kind of work my way towards the center, there's one number left over, so that would be also 93%. Now, something else to note, I personally do division. So 7 divided by 2 is going to give me 3.5, so that says the fourth number, the number after 3, is going to be your middle number. That's just me. If I get an exact number like 5, that means your median is going to fall between the 5th and 6th. Okay, let's do mean. Now again, still not a lot of fun. I am going to change color because that's just way too much black. And let's add 85 and 88 and 90 and 93 and 93 and 94 and 97. And then we're going to divide by 7. And we're just going to pair them up and add them up this way. So we get, let's see, 13, 16, 173. And then we're going to get, I'm going to do it this way, 93 twice. Let's do it. Have a 999, that's 27. And then 3 and 3 is 6, so 276. So I added my tens digits, I added my ones digits, and then combined them together. And then 94 and 97 is going to give me 191 all over 7. And then we're going to keep adding. So let's see, we get a 9, we get a 14, we get a 4, plus 191 over 7. Let's see, we get a 10, we get 14, we get 6 over 7. So if we're going to divide 7 into 640, it goes into 64 9 times, which is 63. We get difference of 1. And 7 goes into 10 once, with 3 left over. So we would say that it would be 91 3/7%. Okay? Now, one thing that I noticed was strange is that on the first one, the mode was way different than the median and the mean. The median and the mean were pretty close to each other. On this one, all 3 of them were pretty close to each other. So what you're seeing that's affecting your calculation is if you have some outliers. Also, you can look at how far apart your numbers are, a range, and we'll talk a little bit more about that on the next video. So, interesting. All right, we got one more I wanted to talk to you about, and that's dealing with the notion of a dot plot. So I'm going to give you one more set of data, and this is going to be given in this graph. Oops, maybe I should title it correctly. High temps. And so what I mean by a dot plot is you're going to see a portion of a number line, only the portion that's relevant to what you're working on. So we're going to go from 44 to 54. I might have to expand this. Yep, I didn't go far enough. Ooh, that went really far. Let's try that again. That's better. And then you're going to see dots where things landed. So, and when dots are on the top, it means there were 2 45s that showed up. And then a 47. And then a 49. And a 50. And a 52. Okay, so this is called a dot plot because you use dots, dot plot. Let's try that again. Dot plot. And you use dots to show you the data. Now with dot plots, each row should be in line with each other so you can tell the difference from one row to the next. So it's really easy to count things very quickly. Now, what some people will do will take this data and create what's called a stem and leaf plot. And all the stem and leaf plot does is it's going to separate the tens digit from the ones digit. Sometimes in a stem and leaf plot, it separates the ones digit from the tenths digit. So there's different ways of organizing. But when you have a lot of data, sometimes it just makes it nicer to put it in a stem and leaf plot. And what's nice about a stem and leaf plot, you can also figure out mean, median, and mode from it. So we have a 44 and a 46 and a 48. So we write the stem of 4, and then we take the leaves and we put them in order from least to greatest. So actually it was 45, 45, 47, and 49. So that's how I show those 4 numbers. Pretty crazy, huh? And then we would have another stem of 5 to be the 50 numbers. And there was a 50 and a 52. So 50 and a 52. And so things line up vertically as well. Now, they will give you, I'm going to shorten this up, kind of like a key, and the key teaches you how to interpret what you're reading. So a lot of people like to pick the first one or the last one, and then you would say means 45. Okay, so looking at your dot plot or looking at your stem and leaf plot, mode is very easy to see. It's what shows up the most. Well, I had one number that had 2 dots, and the rest of them had 1 dot. So the mode in this case is going to be that number 45. It showed up the most. Median. Median. So then the median is going to be the number in the middle. So let's count up with 1, 2, 3, 4, 5, 6 numbers. Okay. So I'm going to show you how to do it both with the dot plot and the stem and leaf plot. So that means it's going to fall somewhere between these 2 numbers. So it's somewhere between 47 and 49. That's where we're going to find our median. Well, most people, even looking at that dot plot number line, we can see that our median is actually going to be 48. And I forgot, this is probably degrees Fahrenheit, so I'm going to add labels in here. Now, looking over at my stem and leaf plot, I'm going to go 1, 2, 3, and the median would fall between the 7 and the 9, because then that would give you 1, 2, 3 numbers after it. So again, what's between 47 and 49? 48. Okay? Now mean, oh man, mean is so easy with a stem and leaf plot, or at least it's a lot easier. So I'm going to use the stem and leaf plot on this one. So I have 40, and I count up my leaves. 1, 2, 3, 4. So I have 4 numbers in the 40s, plus I have all the leaves. 5 plus 5 plus 7 plus 9. All right? Then let's count how many in the 50s I have. Well, I have 1, 2. And then I'm going to add the leaves. Okay? And then I'm going to divide by how many numbers there were. We've already determined there are 6. It's just a faster way of doing it. You can always just add them one at a time. So we get 160, we get 10 and 16 is 26. We get 100, and we have 2. So I kind of like to pair up my numbers this way. So I get 260 plus 28 over 6. And I get 882 over 6. So I do division. 6 goes into 28, let's see, 4 times, which is 24, with 4 left over. And 6 goes into 48 exactly 8 times. So we would have the median would be 48 degrees Fahrenheit. So notice here, again, the 3 numbers were pretty close, and that's because there wasn't a huge spread of the numbers. All right, guys, there we are. Sorry for the long notes, but that's what happens when you put 2 lessons together. All right, we'll talk about it in class on Tuesday. Bye now.